Hello everyone. The next problem is m by 2 game. So consider the payoff matrix of player A. Solve it optimally using graphical method. This is having 4 rows and 2 columns. M by 2, only having 2 columns, having 4 rows. Now to do such type of problems, now the same graphical method I am going to solve. Now in the same way, row minimum, column maximum you have to find out. Check whether maximin is equal to minimax or not. Row minimum, first row minimum, second row minimum, third row minimum, fourth row minimum identify. First column maximum, second column maximum you identify, and out of all these minimum values, identify the maximum value. 1 is the maximum value, 2 ones are there, any one we can take. This is the maximum value, and out of the maximum values, the minimum value identify. The minimum is 3. Now maximin is not equal to minimax value, therefore the game has no saddle point. Therefore and it is no saddle point, and it is having only 2 columns. That's why having only 2 columns, we can solve it using a graphical method. If it is having only 2 columns, we can solve it using graphical method. You observe this payoff matrix. Now after this, now check whether dominance property, if dominance property is applicable for only rows, because only 2 columns are there, it is fixed. Don't apply dominance property for columns, apply dominance property for rows only if applicable. If it is applicable, apply dominance property and reduce as simple as possible. If it is not applicable dominance property, you can we can directly we can directly draw the graph. None of the rows of the game can be deleted using dominance property. That means the dominance property is not applicable. If it is not possible to apply the dominance property, just leave it. Now we will draw the graph. Now here, to draw, while drawing the graph, in the previous problem we have taken let x be the probability of, here we will take y. Let y be the probability of selection of alternative 1 by player B. B. See, this is the given player alternatives of player B, 1, B1, B2. This is fixed. Player B alternatives B1, B2. Player A alternatives 1, 2, 3, 4. It is not possible to reduce alternatives of player A. That's why we are drawing all the lines 1, 2, 3, 4. Now let y be the probability of selection of alternative 1 by player B, and 1 minus y be the probability of selection of alternative 2 by player B. Therefore, just like the previous problem, A's alternative, here A's alternative is 1, 2, 3, 4. B's expected function value. Now here, just to see, y, 1 minus y, 1 into y plus 3 into 1 minus y, 3 into second row, 3 into y plus 1 into 1 minus y, 3 into y plus 1 into 1 minus y. Third row, 5 into y plus minus 1 into 1 minus y. Fourth row, 6 into y plus minus 6 into 1 minus y. Y, we assumed let y and 1 minus y be the alternatives of player B. Now that's why we have got like this, and if you simplify, the values you will get like this. The computations of expected loss gain of B with respect to each of the alternatives of A when y is equal to 0, y is equal to 1. In the previous problem, when x is equal to 0, x is equal to 1. We assume like that. Now, when y is equal to 0, what is the value of this one? When y is equal to 1, what is the value of this one? When y is equal to 0, how much? When y is equal to 1, how much? We will draw the table. Same, alternatives of A, 1, 2, 3, 4. B is expected minus 2y plus 3, 2y plus 1, 6y minus 1, 12y minus 6. The same. When y is equal to 0, how much? When y is equal to 1, how much? When y is equal to 0, how much? When y is equal to 1, how much? All the values we have to find. After finding all the values, using these values only, we have to draw the graph. Now y is equal to 0. This is not x is equal to 0. This is y is equal to 0. 1 second. When y is equal to 0, y is equal to 1. Y. the values y is equal to 0, y is equal to 1. Y is equal to 0, y is equal to 1. In between 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. 0.1, 0.2, 0.3, 0.1, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Parallel 1, 2, 3, 4, 5, 6, 7. Negative -1, -2, -3, -4. Parallel. Parallel -1, -2, -3. Here also -1, -2. This is parallel. Now first value 3, 1. 3. Where is 3? 3, 1. Draw the line 3, 1. And the next value is 1, 3. 1, 3. 3, 1. 1, 3 also we have to draw like that. A1. These are all A1. A's alternatives. That's why A1, A2, A3, A4. This is A4. This is A1, A2, A3. Draw all the 4 lines. After drawing all the 4 lines, since B is a minimax value, that's why we have to identify the upper boundary. Since B is minimax value, in the previous one maximin value, here since B is minimax value, the previous one is maximin, since B is minimax player, that's why after drawing all the 4 lines like this, identify the upper boundary. Why upper boundary only? Because B is minimax value. That's why upper boundary. Upper boundary, first we will identify upper boundary. After that, give names to the upper boundary. This is A, B, C, small d. A, B, C, D. After drawing the lines, the names of the lines are A1. This is A1 line. This is A2 line. This is A4 line. This is A3 line. Like this you will get. Now identify the upper boundary. In the upper boundary, identify the lowest point. A, B, C, D is the upper boundary. Identify the B. Since why we are identifying the upper boundary? Since B is the minimax player, identify the lowest intersection point in the upper boundary. Now here lowest intersection point is B. B is the intersection of which 2 lines? B is the intersection of A3 as well as A1. Remember, B is the intersection of A3 and A1. Since B is a minimax player, identify the lowest intersection point in the upper boundary. The upper boundary consists of the intersection points A, B, C, D. Out of these points, the point B is in the lowest level. Now B is the intersection of A1, and A2 or A3, that is your wish, because the intersection of 3 points here. This is the intersection of 3 points, A1, A2, A3. B is the intersection of A1, A2, A3. That's why either A2 or A3 you can take, that is your wish. Columns, first column, second column fixed. This is first column, third column, A1 and A3. Line A1, B is the intersection of A1 and A3. Player A1 and A3. 2 by 2, we reduced it to 2 by 2. Reduced into 2 by 2. After that, using the formula P1, P3, P1, P3. This is A, B, C, D. Using the formula P1, P3, because first column, first row, third row, P1, P3 and Q1, Q2. Find out using the formula. After that, value of the game V is equal to, find out the value of the game. Value of the game V is equal to, and hence the strategies of A and B are. Strategies of A having how many column, how many rows? 1, 2, 3, 4. P1, P3. P1 value, P3 value. The remaining 2 zeros. B. Q1, Q2. That is the answer. Value of the game V is equal to 2. Like this you have to find. Strategies of A and strategies of B. In the given problem, how many rows are there? A having how many rows? 1, 2, 3, 4. Out of 1, 2, 3, 4, P1, P3 we know. P2, P4 zeros. B. only 2 columns, P1, Q1, Q2, value of the game. Like this you have to do. Thank you very much.